Welcome to Maths with EJD. In this video, I'll be solving some structured problems bordering on metric space, in particular, some properties relating to metric space. And the first question goes this way. We need to find, it goes this way. In R squared, that is two-dimensional real number system, define r squared by r squared, that's two-dimensional by two-dimensional, mapped to one-dimensional R system, and you define that by P of xy, which is equal to summation from I equals 1 to 2 of the absolute value of xi minus yi squared, all raised to power half. Okay? And we need to show that P is a metric, on R squared. So we need to show that P is a metric on R squared. Okay, so let's go. Well, basically what we just need to do here is to prove the four properties of a metric for this particular expression P of x comma y. Now, and the four properties are simply this. Okay, let me just say solution, right? So we need to prove the four properties of a metric for P of x comma y. That's all we need to do. Okay. And the first property is the property of non-negativity. And that simply says that the P of x comma y is always greater than or equal to 0 for all x and y in the real number system. Okay. And then we have what you call indiscernibles, identity of indiscernibles. Yes, identity of indiscernibles. And what that simply says is that P of x comma y is 0 if and only if x is equal to y. And you need to understand that anytime you have if and only if, it means that you have to prove it from left to right, from here to here, and from here back to this place. Okay, that is what if and only if implies. And then there is symmetry, right? There's also the property of symmetry. So that means P of x comma y is the same thing as P of y comma x for, okay, let me just use that math notation for all x comma y in the real number system. And lastly, you have the triangle inequality. And what that says is that P of x comma z is less than or equal to P of x comma y plus P of y comma z. It's more like it takes less time or equal time to move straight from one place to another or to break the journey, something like that. So, and of course, this for all x, y, and z that are real. Okay. So those are the four things we need to prove. So in this case now, we have the expression is unique in its own way. And this is it. That P of x comma y is equal to P of x comma y, right? Is equal to summation from x equals 1 to 2 of the absolute value of xi minus yi all squared. All of this raised to power half. That's what we have. So let's start with the first one. I will start with the first one. That is the non-negativity idea. non-negativity, non-negativity. Okay. For non-negativity, right? By intuition, you can already see that if you look at this part now, so it is guaranteed that the absolute value of xi minus yi, in fact, taking absolute value alone is already, this alone is already positive. This is already greater than or equal to 0. And same, even if you now square it, xi minus yi squared, that is still greater than or equal to 0. Or if you like, you want to stretch it further, and then you have, so this thing that is greater than or equal to 0 now, if you still sum it up, from x equals 1 to 2 of xi minus yi, so summing it up is still positive. And then now taking square root of something positive, okay, this is squared, right? Now taking square root of that, it is still positive. So however you look at it, you can say that P of xy, you can say therefore P of x, comma y is greater than or equal to 0. So the non-negativity rule is taken care of. Okay, so let's go to B. We talk about the identity of indiscernibles, identity of indiscernibles. And what that simply talks about is the fact that P of x, comma y is equal to 0 if and only if x is equal to y. So you have to prove it forward and backwards. Okay. Again, you remember that P of x, comma y is equal to this summation from x equals is it x now? Or it should be I, right? It should be I equals 1. I think it's been I equal 1 from the beginning. So this should actually be I equals 1. Okay? Not x equal 1. That would be a confusion. So this is I equals 1. So here, it should be I equals 1, absolute value of xi minus yi, all squared, and then we take the square root of this. So for identity of indiscernibles, right? So we can start by saying that if P of x, comma y is equal to 0, so that simply implies that means that that means that this whole expression is equal to 0. And technically, at the root of that is the fact that xi minus yi squared equals 0, That's essentially what that is. And then if you take the square root of both sides, right, you have absolute value of xi minus yi, equals 0. Okay? And then that means that xi minus yi is equal to 0. So, and then that is xi equals yi. Whatever the value of I is then, that means that x is equal to y. So you see, you start from P of xy equals 0, and you end here, all right? So in the same way, that's you going from left to right. So if now prove it from right to left now, from right to left, So in that case now uh, you say if x is equal to y, right? That implies, so it's like going back. So it means xi is equal to yi. And if that is the case, it means xi minus yi is equal to 0. And that simply means that xi minus yi xi minus yi is equal to 0. And if you square both sides, that means xi minus yi all squared is still equal to 0. Well, what else do you want to do? You want to sum it, right? If you sum it from I equals 1 to 2, xi minus yi squared, it's still equal to 0, right? And then, you can then do this summation from I equals 1 to 2 xi minus yi all squared raised to power half equals half of 0 raised to power half is still 0. So at the end of the day, you still have your pxy equals 0. So either way, so if and only if means you have to prove it from right to left. Here now, this is proof proof from proof from left to right. That means you're proving it this way, and right to left, that is, you're proving it this way. So this is not right to left. So overall, basically, therefore, a P of x, y equals 0 if and only if x is equal to y. That is settled. All right. So we can go to talk about the third property of symmetry. Symmetry. Let's talk about symmetry. So talking about symmetry, right? Symmetry simply implies that P of x comma y is equal to P of y comma x for all x and y belonging to the real number system. Basically, that's what symmetry is about. And of course, what we have is P of x comma y equals summation from I equals 1 to 2 of the absolute value of xi minus yi all squared raised to power half. Okay? So, I mean, we can go ahead and say this is summation from I equals 1 to 2, then of the absolute value of, you can say this is, um, you can say this is what can we say here? Can we factorize minus? So we have minus into xi plus yi, something like this, all squared raised to power half. This is still, does this work? Yeah. So this is okay, yeah. If we factorize minus, then we have minus here, right? So minus times minus is plus, so we have plus xi. Minus times plus is minus. So yeah, this works. So and then that's some shared skill, mathematical skill. I equals 1 to 2, and then this is minus yi minus xi, right? Like this, all squared, and then all of that raised to power 2. So raised to power half rather. And then this is summation from I equals 1 to 2. Now, because you're taking absolute value, right, the minus doesn't matter. So the minus can go. So you have yi minus xi raised to power half, or raised to power 2, or raised to power half. And now, what does this look like? This is looking like y is coming first. So this is as good as saying this is p of y comma x. And then that proves the fact that if you start p of xy is the same thing as p of yx. By that skillful movements we made from around this place. So that also settles that. So we can say therefore p of xy is equal to p of yx for all x comma y in the real number system. Okay. All right, so that's about symmetry. Now let's go for the last one, which is the idea of triangle inequality. Triangle inequality. Triangle inequality. Triangle inequality. Okay. So for triangle inequality, right, we have P of xy again to be this summation from I equals 1 to 2 of the absolute value of xi minus yi raised to power 2 all raised to power half. Here, we also need some skillfulness to deal with this. So can we, first of all, so triangle inequality. Yeah, this is the definition we have, right? And then triangle inequality says that okay, I think it's better I start with the definition of triangle inequality before I begin to talk about this. So triangle inequality simply tells us that P of xz is less than or equal to P of xy plus P of yz. That's what triangle inequality says for all x, y, z in the real number system. That's what triangle inequality is about. So, and we need to prove this for this function P of x comma y, right? Which is equal to summation from I equals 1 to 2 of xi minus yi raised to power 2 all raised to power half. So, of course, so this is basically this, right? So we're going to start with, we start with this and P of yz, P of yz would simply be in terms of this summation from I equals 1 to 2 of yi minus zi raised to power 2 all raised to power half. So that's taken care of. So can we look at this now? If we say, um, you know, we can have, we can actually do this. We have absolute value of xi minus yi, plus yi minus zi, like that. And, we can say this is less than or equal to absolute value of xi minus yi, plus absolute value of yi minus zi. Okay, so it's basically some inequality things relating to these kinds of expressions. So if you do it that way, um, so we can proceed as follows. So we can proceed from that as we begin to do that. Okay. So if we take the summation, now of course you can already see that this can easily cancel out as from what you can see. This is like the absolute value of xi minus zi, and that is less than the absolute value of xi minus yi plus yi minus zi, like that. And we can take the summations, right? Since this has been established, then we can just go all the way. So we can then take summation from I equals 1 to 2 of the absolute value of xi minus zi, you know, and then, okay, well, before we even take summation, I think it's sensible to take squares. It's sensible to take squares. So we have xi minus zi squared less than or equal to absolute value of xi minus yi squared plus yi minus zi squared, Then the next thing we can take the summation. So we have summation I equals 1 to 2 of absolute value of xi minus zi squared less than summation from I equals 1 to 2 of absolute value of xi minus yi all squared plus summation I equals 1 to 2 of absolute value of yi minus zi squared. And then we have just one layer to go, and that is that, the square root of this whole sum. So we have summation from I equals 1 to 2 of absolute value of xi minus zi squared all raised to the power half less than or equal to summation from I equals 1 to 2 of xi minus yi all squared all raised to the power half plus summation from I equals 1 to 2 of yi minus zi all squared raised to the power half. So now we have everything sorted. So it means that P of xz, as by the definition we started with, is less than or equal to P of xy plus P of yz. And then triangle inequality is taken care of for that question. So that's the first question, uh, in this case. So the second question, right? Oh, okay, this question is A. I've gone ahead naming all these ones A again. So I think it's better to just call this one Roman figure I, Roman figure II. That's 2. And then call this Roman figure 3, III. And then Roman figure 4 for the fourth condition, IV, like that. Okay, so that's the first question in that sense. So can we go to the second part of the question, which is equally interesting? So in this case now, what we have is this, what we can call B now. Or let me use a very bright color here. Okay, let me go this. So B, see what we have. We want let P be any metric. Let P be any metric on X which belongs to the real number system, right? And that is the real line, the real line, the real line. Okay. So the question is P prime X comma Y, which is P of X comma Y all over 1 plus P of X comma Y. Is this also a metric? Also a metric? Metric. on x, I mean the same x on x. That's the same x here. Okay. So, and then we need to show that. So verify stating your reasons. Verify stating your reasons. So what you are just supposed to do again is exactly what we did before for the previous question. We need to show all the properties that they hold for this again. Okay. So let's go. Yeah. So again, we need to just verify all the four properties for this particular expression. So now the only thing is that we have a basis. We have a basis that P is already a metric. It is established. So if P is already a metric, then it means that, okay, I mean, let's just go instead of just talking. So it means we already have a P of X comma Y, which is uh P is a metric already established. So if P of X comma Y is a metric, then it satisfies all the all the four all the four properties all the four properties of a metric, namely 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 non-negativity non-negativity, and then uh something indiscernible. I keep forgetting that expression. Identity of indiscernibles. Yes. Yeah, identity of indiscernibles. Identity, identity of indiscernibles. Then it also obeys symmetry. It follows symmetry and triangle inequality. So it is established. So based on the question, right, we have that P is already a metric. So that's settled. So based on P now, we want to now see if P prime is also a metric. So that's the job we have to see if P prime of X comma Y, which is simply P of XY, which we already know is a metric, all over 1 plus P of X comma Y. Okay. So we want to see if that is also a metric. So we have to check all the four rules, all the four properties, right? So in that case now, let's go and check number one to check non-negativity, non-negativity, non-negativity. We already know that P of X comma Y is already non-negative. It's greater than or equal to 0. If that is the case, it means that 1 plus P of X comma Y is still non-negative. So whatever happens, so we can say therefore P prime of X comma Y, which is equal to P of X comma Y, non-negative, all over 1 plus P of X comma Y, which is also non-negative. You know, overall everything is non-negative. So that's a very nice argument to follow. So we can say, so P prime of X comma Y, P prime of X comma Y is greater than or equal to 0. Settled. Okay. So we go for the next thing, which is identity of indiscernibles. And what it simply says is that whatever it is, P prime of X comma Y would be 0 if and only if X is equal to Y. If and only if X is equal to Y. And in that case now, you have to prove it forward. That is, start with this and end up here. And you have to prove it backwards. Start with X equals Y and end up there. So that's how to deal with that. Okay, so let's see how we go first. All right. So here now we see that P prime of X comma Y. So if P prime of X comma Y is equal to 0, that simply implies that P of X comma Y all over 1 plus P of X comma y is equal to 0, right? So if you cross multiply, 0 multiplies this, 1 multiplies that. So it means that P of x comma y itself is equal to 0. And what is P of x comma y? P of x comma y is simply the metric of x and y. That's the distance between x and y. That's the absolute value of x minus y, and that is equal to 0. And of course, we can just say this is x minus y equals 0. And that means x is equal to y. So now this is established. We started from here. Now we are here. So we have done it from left to right. So let's go from right to left now. So in that case, now we say if x is equal to y. So it's more like you just want to go back. So if x is equal to y, that simply means that x minus y is equal to 0. X minus y equals 0. And this implies that the absolute value of x minus y is also equal to 0. That means that P of x comma y is equal to 0. And if P of x comma y is equal to 0, right? What does that tell us? It means that um if we add 1 to it, right? Okay, what am I saying? Okay. P of x comma y is equal to 0. And of course, if P of x comma y is 0, right? So, x equals y is leading us, this x equals y is leading us to the fact that P of x comma y is equal to 0. So that simply means that P prime of x comma y, which is defined in terms of P of x comma y all over 1 plus P of x comma y, would simply be 0 all over 1, plus 0 again. You get the gist? So this is 0 over 1. And P prime of x comma y is 0 again, because x equals y implies that P of x comma y is 0. So if you put all that into this expression, we end up getting 0. So you see now that, x equals y leads us here. So at the end of the day, we can say overall, therefore, P prime of x comma y is equal to 0 if and only if and only if x is equal to y. So that is established. So that is the identity of indiscernibles. So we go again to talk about symmetry. Let's do symmetry. So for symmetry, see how we go. Um, that's I think I've started labeling that. Okay, 2 now. So now 3, Roman figure 3. So that is about symmetry. So we already see that P prime of x comma y is equal to 1 plus P of x comma y all over, no, the other way. Uh, that is 1 plus, no, that is P of x comma y all over 1 plus P of x comma y. All right? That is what we have. So, but I mean, we can, this is the same thing as P of y comma x. At least that is true for P because we already know P is a metric and it will obey that law. Then that means we also have 1 plus P of y comma x. So if that is the case, then we can say this is still P prime of y comma x. So, of course, the whole idea of symmetry is that P prime of x comma y is equal to P prime of y comma x. And so for all x and y belonging to the real number line. So now we just have this. So it's like easy peasy. So we can say therefore P prime of x comma y is equal to P prime of y comma x for all x comma y in a real number line. So, because even if you don't know it, like from what you already have, right? This is the original P of x comma y, which has been said to be a metric. So if it is actually a metric, then it obeys the law that P of x comma y is P of y comma x. And from there you can apply it to what you have now. So symmetry, check. So we have finally um the idea of triangle inequality, triangle inequality, triangle inequality. So in this case, of course, some skillfulness is also required. Some skillfulness is necessary here. So see what you do. Um, we already know the definition of P of X comma Y, right? So if you have P prime of X comma Z, that will simply be P of X comma Z, right? All over 1 plus P of X comma Z, based on the definition, that's what we have. And what can we do? We can split this P of X comma Z. We already know for P now, since P is already a metric, then it should obey that law of symmetry, that triangle law. So P of X comma Z, we can actually say it is P of X comma Y plus P of Y comma Z. And again, this over 1 plus P of X comma Y plus P of X comma Z. Okay, so now this is P prime. Now P prime of X comma Z is all that. Now let's see. Now P prime of X comma Z to be equal to. Now you can split this up now. So you have P of X comma Y all over 1 plus P of X comma Y plus, okay, of course, plus P of X comma Z. So it's more like if you have A plus B over over 1 plus A plus B, right? So you can split it. So the top determines how you split it. Okay. So each one will carry whatever is at the bottom. So here now you have P of Y comma Z all over 1 plus P of X comma Y plus P of X comma Z. No, actually, this should be Y comma Z. This should be Y comma Z. This is Y comma Z. Y comma Z like that. Okay, again, this is Y comma Z. Okay, X, Y, Y, Z, like that. Okay, now see what is going to happen here. So from what you've split now, you know that 2 over 4 is half, right? 2 over 4 is 1 over 2. But if you reduce the denominator and you have 2 over 3, that is, this is 0.5, but then this is 0.677. So if this is equal to this, if you reduce the denominator for each side here, it means that this expression is going to be less than or equal to whatever you have here. So what exactly we are going to do is now to so for this part now, for the first part, you have P of XY. So for that, okay, let me just let me do a bit of drama for that, so you can really understand. So you have P prime of X comma Z. So now it's less than, let's assume it is still less than, I mean equal to, rather, it's equal to P of X comma Y all over 1 plus P of X comma Y plus P of Y comma Z plus P of Y comma Z all over 1 plus P of X comma Y plus P of Y comma Z, right? Now see what is going to happen here. So because here we have P of X comma Y, we can cross this out. Because here we have P of Y comma Z, we can cross this out. You see that? So, and as you cross this out, it means you are making the bottom bigger. And if you make the bottom bigger, it means the values will be smaller. So by doing that now, it means this is gone. You are going to have less than or equal to. Okay? So it means you are going to have P prime of X comma Z now to be less than or equal to P of X comma Y all over 1 plus P of X comma Y plus P of Y comma Z all over 1 plus P of Y comma Z. And of course, that now fits into the definition of P prime of X comma Z less than or equal to P prime of X comma Y plus P prime of Y comma Z. And that is all we need to show. So at this point, we have come to the end of these two questions, A and B. If you have not subscribed to this channel, you want to be sure to do that. You also want to share with your friends, let them subscribe to, because all these things are really going to be helpful to them. And then, of course, always like, share, and comment. For instance, this question was a comment from one of my followers, one of my viewers who uh, wanted me to solve this, and that's why I've done this now. So be sure to always come by, subscribe, hit the notification bell so you can get alerted when I release a new video, and share, comment, like, and we'll always have a nice time studying maths together. See you in the next video.